All right. Then we followed by the formula we saw convergence is equal to Shillong or Delong in degrees and not in minutes. We are not changing it in minutes by multiplying by 60 and then multiplying it by sine of mean latitude.
Yes.
Then higher the latitude, more the convergency. More Shillong, more is the convergency. Means as high as you go. Since the formula suggests that it is directly proportional to sine,
Yes.
right? Sine at equator is sine 0.
And
Sine at poles is sine 90. So the value of convergency will be increasing if you increase the latitudes, right? So higher the latitude, more the convergency. If the Shillong is more, since the convergency formula depends on Shillong and sine of mean latitude, right? So if you
yes, ma'am.
increase Shillong, convergency increases. If you increase the angle, that is the latitude, the convergency will increase, right? At any point of Earth, the true north is defined with the direction with reference to the direction of the local meridian. If you are at any different meridian in flight from the point of local meridian, from where you started, your local direction of true north has changed. This is what we saw here. That if I am going from one point to the other point on any particular local latitude from one point to other, my north is changing. Initial north direction was this, final north direction looks like this. So if I find the difference between their directions, I would know the convergency,
Yes.
right? So these are the points which you have to study. We discussed about this last time at the equator. At equator, we have zero convergency. Since they are converging like this, so, and this was another diagram for convergency that all of the meridians are converging at poles. Today, what we had to study was the conversion angle, right? Now, conversion angle is the angular difference between a great circle and the rhumb line. What does this mean? Yesterday, we saw in the Northern Hemisphere, great circle would be a curved line, and straight lines are the rhumb lines.
Mm.
This is the diagram we drew last time.
Yes.
Remember this one? On the real Earth, the great circle track is a curved line, and rhumb line is generally a sorry.
Is it?
In real Earth, rhumb line is generally a curved line, and great circle is a straight line. It is the same straight line between any point A and any point B. This great circle gives the shortest distance, whereas rhumb line, as the name suggests, it is a line of constant angle. It would be a curved line converging towards the nearest pole, right? But when you draw
Yes.
this diagram, when you just imprint the Earth on paper, on a chart, or on a map, these lines, they become the straight lines. Which one becomes straight? The rhumb line is drawn as a straight line on a Mercator chart, and GC is drawn as the curved line on the Mercator chart, right? In the northern hemisphere, it is curved concave towards the equator, right? In the southern hemisphere also, it is turned curved concave towards the equator. Then it is in the southern hemisphere. It is the rhumb line, it is the great circle track. This is what we had studied last time, right?
Yes.
Okay. Now, what is the conversion angle? This angle between the great circle and drum line, this angle is known as the conversion angle. We'll discuss it. How did we get this angle only as a conversion angle? First
Okay.
thing to remember is great circle final minus great circle initial. What does it give? It gives us convergency.
Angle. Okay.
Gives us the convergency angle. Not angle, it just gives us the convergency. Now we will see what is the conversion angle. As discussed, it is the angle between the great circle and the rhumb line, right? And
Hmm.
convergency angle, the conversion angle is half of convergency. So the angle will be half of convergency. Half, what is the formula for convergency?
Chilling into mean a sign of mean latitude.
Good. So convergency angle will be this one, right? Good. Now we have to discuss what is the need to apply conversion angle and basically why are we studying the conversion. So on Earth, great circle is a straight line and rhumb line is a
Hmm.
curved line. We're talking it on the Earth, right? Because rhumb line is a line of constant angle. So it is always curved and it spirals towards the nearest pole, right? And radio signals are following great circle bearing. All the radio signals, they will follow the great circle bearings. They will follow the GC tracks. Okay. But the plotting is done on the Mercator chart. Earth is a sphere and you are just trying to take the imprint of that globe, of that sphere on a paper. So when that meridians, longitudes, latitudes are drawn on a sheet of paper like this. So on this paper, the rhumb lines are drawn as the straight lines and the great circles are drawn as the curved lines for the northern hemisphere like this, and for the southern hemisphere like this, right?
Yes.
To plot radio position lines on Mercator chart, great circle bearing will have to be converted into rhumb line bearing, and which is achieved by applying the conversion angle. That means if my great circle track is given and I want to find the rhumb line track, or if my rhumb line track is given and I want to find my great circle initial or final track, I can apply this angle and get to know the specific value for rhumb line and the great circle tracks. Okay,
Yes.
good. Now we need to apply convergency because the north keeps changing from one meridian to other. At one meridian, north might look like this. At other meridian, the north might look like this. At third meridian, the north would look like this. So the north is
Yes.
changing. See, the angle between the norths is changing. Do you agree to this? That the north is changing its direction depending on the meridian.
Very
So
good.
if you are moving from one point to other, you should know, right? How much angle do you have to add or subtract from this meridian so that you will reach at the correct direction. That
Yes.
is why we are learning about convergency, conversion angles. Okay. Now in aviation, all directions are measured from north. And in clockwise direction. Are you happy about it? Whatever I have written.
Yes.
This is north. Starting from here, I can say this is 000 degrees. If I want to calculate any particular angle, I'll start my calculation from this point. This will be my reference point, the straight line. If I want to go 20 degrees, then this is the line From here 20 degrees. This will be 20 degrees. 0 to 0. If I want to go 45 degrees, I'll start from this vertical line. This is my reference line. Reference is north. 45 degrees. I'd go like this, making an angle of 45 degrees. If I want to go in the 90 degrees direction, that is the east direction. This will be east. 0, 9 or 0 degrees. Similarly, if I say you, okay, Sujan is starting from this point and he is going in a direction 130 degrees. That means this is Sujan's head facing towards north. From north he calculated the angle of 130 degrees and went in this direction. This is how we are going to go. Do you know something about clock directions? Any idea what is clock?
The angle made by the two hands of the clock, if I'm not wrong.
Given by the two hands of clock, the smaller clock and bigger clock. So this is how you know the directions of clock. Now, if you have to tell your position to someone, generally used in militaries, how do they tell direction? This is Sujan here. This is Harshita here. Okay. If I contact you that, okay, Sujan, can you see me? Where am I with respect to you? So you will say, ma'am, you are at 2 o'clock. Okay. If I was here, you would say that I am at your 3 o'clock.
Yeah. 6 o'clock.
6 o'clock. And but if I have to tell you my position, where am I with respect to you? I will say I am 8 o'clock with respect to you. Right? My needle will be like this 12, 3, 6, 9. Nearly you can say 7 or 8. Right? This is
Yeah.
what is meant
From
by
your
giving directions in clock direction. Okay? Now, if I say you have to go in east direction, what do you think is the east direction? This is the line, this is the east, and this is the west. So how will you, when will you say that you are going towards the east direction? Not exactly, I'm not saying that you have to go exactly at 0, 9 or 0, then only it's east direction. Towards the east direction if you have to go. How will you say you are going towards the east direction?
like from traveling from 0 degree to 90 degrees in between, we'll tell that we are traveling from north to east.
Okay. If you are moving in east direction, then you can say that you are going between 0, 0, 0 degree, no, not 0, 0, 0, from 0, 0, 1 to 179 degree. 0, 0, 0 only, not 1. From north till this angle 179er, this direction is known as the east direction. This means you are going towards the east. This is the place A, this is the place B. I'm asking you to go at place C towards the east. This will also be considered as east direction. This is also the east direction because you are going, if a line is drawn and if you are going this side of the line, then you are going towards the east direction.
East.
If you're going towards this side,
West.
you're going towards the west direction. Good. Now, what will be the west direction? From here to here?
180 to 360.
182, 359. This direction will be considered as the west direction,
West direction.
right? Good. Now, let's see one example. You are going from point A to point B in the northern hemisphere. Okay? A to B. That means you are going like this. Since you are in northern hemisphere, your track, your great circle track would be like this. Happy with the diagram?
Yes.
Okay. Now, I'll say that rhumb line A to B is 1 to 0 degree. Okay? And great circle track A to B at A is 115 degree. All right? You have to tell me great circle track B to A at B and the rhumb line track from B to A. Also tell convergency. Let's see. What all information have I given you? Rhumb line track A to B 120 degree, right?
Yes, ma'am. Yes.
Actually, the diagram is wrong if I consider it as 120 degree. Can you tell me how?
Yeah, it should be straight like
No,
this.
no, it's fine. It, it should have been looking like this, and then like this, something like this, right? But it's okay. For our convenience, we'll just draw it as a straight line because answers are going to be same. Even if you draw it like this, 120 degree from the nodes, right? I told everything will be measured from node. This is 120 degree. And great circle track A to B calculated at A is 115 degree. So from nodes, if you measure, it will be 115 degree. So instead of making the
So,
diagram tilted, we are going to consider making the diagram straight itself.
yeah.
Okay. Rhumb line A to B is 120 degree. So is it 1 or is it 2?
The, it will be between south, east and west. Sorry. East and south, 120 degree
It's okay.
from north.
Since it is between 0 and 180 degree, it is coming in the east only.
Yeah.
Correct. You just have to tell me, is 1 a rhumb line or is 2 a rhumb line?
2 is the Ramla.
2 is a rhumb line when seen on Earth. On Earth, rhumb line is curved, right? But we are drawing it on a Mercator chart. So on Mercator chart, straight
Which
line
is
is the
straight
rhumb line.
Ramla. Okay.
So this is
One
going
with
to be rhumb line.
yes.
So, and given from A to B, from A towards B, the rhumb line value is 1,
120.
2, 0 degree, right?
Yes.
The GC track A to B, this is the great circle track. From A to B, when measured at A, it is given 115 degree. So he is saying the initial great circle track, because you started from A, so it is the initial great circle track. Initial great circle track from A to B, when you are looking at from A, it is given 115 degree. This angle is
Yes.
115 degree. This angle is 120 degrees. This much is given, right?
Yes.
Now, what will be the angle between these two? This is 115, this is 120.
5 degree, like
Yes,
subtract.
it is 5 degree. Very good. This 5 degree, as we have seen today, it is known as the conversion angle, the convergency by 2, right? So this 5
Yes.
degree is the convergency angle, the conversion angle.